turns out I'm on mute. Whoops. So, hi guys, welcome to another webinar on GTG Cloud Singapore. It's been a while since our last webinar. I think the last webinar is sometime in March, and since then, a whole bunch of stuff happened in Singapore, particularly related to the COVID thing that's still going around. Hope everyone has been staying safe. Stay at home. Don't go out too often. And make sure that everyone's good at home. So rather than me just going on and on, life is like kind of sucks now, and we could be in a better state, sometime in the future. Let's go straight to the meat of this whole webinar, which is our guest speaker for today, which is Andrew. Andrew is a APAC technology practice lead for application modernization from Google. And he's the team responsible for delivering on modern applications vision with a couple of big products, Kubernetes, Anthos, and RPG. So let me quickly bring up Andrew to the stream.
Hey,
Hi, Andrew.
how are you?
All right, so let me quickly switch over to your slides, then we can get this webinar rolling.
No problems.
So I guess your slides are up. All good on your side?
Yeah, let's go. So
All right.
thank you so much. My name is Andrew Haschka. I look after application modernization for APAC. And one of the things that I've been trying to bring to Google developer groups all across APAC is resetting back to the basics. I've run a lot of sessions across so many different countries recently, ranging from this topic of monoliths to microservices and serverless and multi-cloud and other things that may impact developers or that developers may directly consume. So I thought, look, given we haven't had a GDG in Singapore with cloud for some time, maybe let's cover off a monolith to microservices topic. Now, this content starts with some market context. It gives a bit of perspective around the customers that I see all across APAC, the resonance that I get for where they choose to develop, run, and lifecycle their workloads. It maybe talks about how we can get started evaluating what workloads are right for modernization rather than just lift and shift or continued maintenance. And then we also cover off a phased approach, 7 different phases on the types of things that you could do to strangle the monolith, to decompose your monolithic application into microservices and run it on a cloud-based platform. So let's jump in. Keen for some questions afterwards as well, if anyone has some thoughts or would like to cover off something next. But just by way of a bit of context, I think it's important to understand where we're coming from in APAC and especially Singapore around what customers are doing differently to Europe and Middle East and North America. Now, these are some global views on seeing a lot of customers run the majority of workloads on premises. Over 75% of workloads are running on-prem. And I see this maybe as a larger figure in APAC as well. I see a definite trend towards multi-cloud and hybrid cloud architectures in Southeast Asia and especially Australia. I see executives wanting to modernize and containerize their applications, but maybe being restricted by the culture of their teams, by the enablement that's available to their teams on running applications in modern containerized architectures. And typically they're looking for automation. They're looking for an easy approach to start modernizing very quickly, which isn't always the case. And it isn't always easy to go and move very fast. But we're going to talk about a couple of different processes that Google has developed to fast track some of these approaches, in addition to the methodology behind how we might want to evaluate an application for modernization. So what does that even mean? If we think about app modernization and how it's impacting and transforming businesses, a lot of people might think about open source technologies with app modernization. Maybe they're thinking about open source Kubernetes, Istio for service mesh, Tekton for build more recently, Knative for serverless. But really, when I try and break it down for an executive, a C-level, we think about 4 key areas that they can make an impact to their overall IT portfolio and their application delivery portfolio for their consumers. And it often starts with applications. I say that many organizations are driven towards generating revenue for their consumers, and that comes from an application. Now, if the application is running in a monolithic architecture, maybe it's got more of a static state, so it's not able to be dynamically updated. Maybe it's got legacy security and compliance frameworks applied to it, and maybe it's not portable. Maybe it just does not run anywhere apart from the current physical server that it sits on. Or maybe it's locked into that cloud running in virtual machines. So the first thing that typically organizations are thinking about within their strategies is, well, we need to move to microservices. That's the premise. Let's move from monoliths to microservices. Let's move away from those physical servers and VMs to containers and clouds to make our workloads more portable. Let's stop doing more traditional waterfall software delivery. Let's take up more agile and CI/CD approaches. Let's develop DevOps capabilities across the board. And let's, I guess, primarily remove our lock-in to proprietary stacks. It might be a proprietary application. It could be a proprietary operating system. It could be proprietary hardware. Or it could be proprietary cloud. We see some applications or workloads being locked into a specific cloud platform. They're not portable. So our vision, I guess, is how do we empower organizations to build applications and migrate applications to open source platforms, but with enterprise scale and production support. So let's go a little bit deeper. You're probably all familiar with the first generation of cloud native that many of us have been driven towards, virtualizing our infrastructure, running infrastructure as code, maybe building 12-factor applications and putting applications on pipelines. Maybe we've got this cloud native center of excellence that is the go-to for all of our cloud native deployments, but it's very much an infrastructure and automated kind of infrastructure platform mindset, and maybe a continuous deployment mindset. Whereas I guess what we see evolving to in the second generation of cloud native is about applications and sustainable scale. So maybe that's around having Kubernetes resource management, but for everything, not just for Kubernetes workloads. Maybe it's around being able to deliver applications on demand from events when they're required, rather than maintaining applications for long cycles when they're not actually being used by consumers. Maybe it's around taking migration approaches and building them into repeatable factories, being able to automate the migration approach and extract away from those proprietary things that we no longer need. And thinking about how we bake in security intrinsically, shifting left on those pipelines, baking in declarative configuration and security management into the platform, being able to maybe have a mesh that allows for that intrinsic security for encrypted traffic between all of the microservices, being able to have service topology views, setting SLOs and SLIs as per SRE practices on the platform, and making SRE available not only to centers of excellence, but to all IT teams. So this is generally the direction that we're trying to encourage and empower for organizations. Now, I would say many organizations I speak to that have started on their DevOps journey, have started their journey to microservices, have read books on site reliability engineering. They've looked at culture for software delivery. They've thought about these 5 key elements of delivering SRE, and there's a whole different session that we could run just on SRE culture on its own. But typically, the basics are accepting failure as normal and reducing organizational silos. And I've come across many organizations that have such a siloed way of working. They've got their architecture and their support teams and their administration teams, and they focus on their individual pillars of Cloud 1 and Platform 2 and Infrastructure 3. And it's really difficult to have that centralized support, that consistent SLA and performance and security across the board when you're running silos. Now, the other aspect is around implementing gradual change. Working in small batches, having design-based thinking, maybe prototyping with a minimum viable product, and leveraging automation and change management where possible, leading through change. I would say the last one, which is typically not done well across a lot of organizations that I speak to, is around measurement. I was in a roundtable for executives recently, and it was not particularly clear across the board of all of these individuals attending how they could measure success for software delivery to their consumers, how they could measure success for delivering software internally, within their organization. And essentially, this culture around measuring everything, having a good benchmarking capability to compare your performance to the industry, and setting good, SLOs based on SLIs. I think transparency is key. Having that data-based decision-making process is key as well. But having said that, modernization isn't just that easy of changing culture. Adopting SRE and having a modern open source-based Kubernetes platform, it's not that easy. In many cases, applications cannot be rewritten very easily. Maybe the people that wrote them are no longer available. Maybe the source code is not available. In many cases, when organizations think about modernization, they first think, well, we should move to cloud. Now, just picking up a virtual machine and moving it to a cloud platform is really not going to address all of your operational and modernization needs. And more importantly, migration is not either a 1 or a 0. It's one of these things that might require an evolution of transformation. So we'll talk about a couple of different things that we can approach this scenario with. And from with a developer hat on, I think it's important to think about how is this going to save the developer effort in reducing rewrites of applications, having applications be more portable that can run and scale anywhere, being able to have consistency of security and performance regardless of the platform that you run on. Because ultimately, it shouldn't actually have to matter where you run your workload. It's more about the form factor that you run it in and the consistency of the ecosystem you can wrap around it. So in terms of the paths to modernization, look, I've spent almost 2 decades doing virtualization of workloads and then containerization, then orchestration. I feel like the best way to do these things in an impactful way for a business is to focus on how we can improve as we move. It's not just about moving a workload somewhere, but optimizing it as part of that approach. And more traditionally, optimization was always just around, well, let's try and reduce the amount of CPU and memory and disk that we can use. Maybe let's try and refine the operating system and maybe the application if we can for the platform that it's running on. But really, it should be much more than that. And moving to cloud, and I see a mixture of clouds, obviously running publicly, but running on-prem too. I would say there is a demand in APAC to run cloud-native apps in a hybrid-based architecture, on-prem and bridging to public cloud, with maybe a multi-cloud strategy. So if we think about the end-to-end journey and some of the things that we're going to cover off in more detail, I was talking to an organization earlier today, and one of the things that we were trying to solve for was they have a large volume of applications. But all we really have is knowledge of the quantity of applications and maybe a small subset on details for the top 10 applications that exist. But that's really difficult to build out a full-scale migration plan and an automated migration approach if you only have a very small view on the detail for the application. And we're thinking about things like dependencies between applications. You know, what application binaries and versions are running on what types of operating systems, and what's the level of utilization at different parts of the day, the week, and the month. And how can we qualify things that may lock an application in to a specific platform or a specific location based on what it requires or how it's being configured or what it's talking to. So discovery and assessment with automated tools is typically, in my experience, a very good way of setting that baseline. Let's set the current state of what it is for that application to go and run on its current stack. Now, I guess assessment comes in the form of workload, but it also comes in the form of culture, and being able to evaluate software delivery culture is something we also do, and we can have a data-driven approach to doing that. You know, we acquired an organization called DORA, the DevOps Research and Assessment organization, in 2018. And it really helps to kind of benchmark where we're at with an organization's culture and how they can get to better. Now, I would say that the next part in the journey comes from setting up that consistent platform and that landing zone that we know is going to meet the SLIs and the SLOs and the SLAs of our applications. And I think it's important to build a platform with automation in mind, where we are baking in all of the policy and security and configuration, all of those things into the stack, so that when we do migrate and build new applications on that platform, the amount of manual effort is reduced because we've basically baked in everything that we need at an enterprise governance level into that platform. Now, I guess the migration approach is something that has traditionally been done maybe quite manually. In many cases for lift and shift, we have automated tools, but we typically don't really do it at the scale that businesses need. And I think it's important to push your organization towards modernizing and optimizing as you make that move. Otherwise, you're maybe picking up something that runs relatively well in its current state, but maybe won't run in the same way on its chosen new platform. So definitely optimization is going to be key. And one of the things that I see as a very good way to start optimization, and it's not you know, the final endpoint that we're aiming for, but it's containerization. You know, if we remove the need for a large surface area of security attack with a smaller form factor container architecture, and we integrate orchestration and declarative configuration management, this is typically making a platform more resilient and future-proofed. So the other thing around optimization is around culture, whether it's SRE or DevOps or other cultures that correlate to effective management and delivery of applications to consumers. Beyond that, taking those containerized applications and building an ecosystem around them. You know, continuous lifecycle management, CI/CD, test automation, maybe release management, and ensuring that your microservices-based application has been optimized for the platform. Now, many organizations I talk to say, look, that's a great vision. That's a good place to start, but we can't quite validate the business value of doing that. How do we know that spending all of this effort on modernizing and optimizing our application is actually going to bring us a business benefit? Now, this is a view from a TCO toolset that we have that can go into that level of detail around what will we optimize as we modernize and containerize that application with that modern application ecosystem wrapped around it. You know, typically staff productivity is one of those things that maybe interesting from a labor reduction perspective, but difficult to quantify specifically as a purpose for investment from organizations that I talk to. But licensing cost savings are very tangible. You can say, look, if we're not running Windows or Linux operating systems and paying for those operating systems anymore and potentially support, then that is a tangible saving that we can evaluate. We can also evaluate how long it's going to take to manually refactor applications and take the application out of an operating system, move it to a containerized architecture. And then we can say, well, if we can automate that and maybe shave off 25%, 50% of that refactoring approach, then maybe that's something tangible that we can count in terms of money we haven't spent yet on refactoring activities. And then there's also business agility with cost relief from, say, CI/CD, where we can come in and say, if you're maybe updating applications on a regular cycle, or maybe you're not updating your feature set for your consumers as often as you'd like, the cost relief from delivering a DevOps-based enabled update and lifecycle management to your application can be fully qualified with a dollar figure. And then being able to review, well, how many failures have we had in releasing apps to production? How long does it take us to recover from failure when we have those? And the benefits that we can get to operational resilience in offering those new modern architectures is something we can quantify too. So this is particularly good to help feed back to the senior leadership team, executive team, say, that here are some business value areas that help to qualify the investment in our project for modernization, and how we can maybe automate some of the things we may be doing more manually as we go and move from monolithic architectures to microservices. So just briefly, mapping out dependencies is key. You know, I see many organizations come in and say, look, we're going to isolate one application and move that to a modern apps platform, to microservices. But they don't bring along all of the dependent services with it, and they end up having a large impact on the performance and even uptime of some other applications as they containerize and move and modernize those specific applications. Maybe they're the ones that you see in red, but all of the other ones in orange maybe have not been brought along. So application dependency mapping is a very key step in the process too, and having an automated tool set like this one, which is Stratazone, will typically help to map that out for you. Now, in terms of the approach, once we've identified those workloads, we've done that discovery, we're going to migrate those workloads to a containerized architecture orchestrated with Kubernetes. We're going to auto-containerize them so that we don't have any, not too much manual labor in the way that we transform and optimize where our applications run, which saves hopefully a lot of rework on the development side, on the infrastructure administrator side. We can also generate CI/CD artifacts automatically for day two operations, which should hopefully save a lot of developer or infrastructure DevOps-based efforts. And being able to automatically migrate both the data and the state should really help save a lot of time and reduce the amount of effort that we spend in that cycle. Now, once we get to step 3 and it's time to optimize, making sure that we don't bake in certain things to the application itself, but we can offload it to the platform, can optimize performance, it can build out security more proactively. And if we've got centralized logging, monitoring, observability, trace capabilities, it can help us achieve our root cause analysis much quicker for these applications running on the modern platform. So how do we identify which workloads to move first? Typically, I see organizations looking at workloads that have a high business value, but choosing the ones that are not mission critical. You don't want to move your mission critical application as a first pilot use case. It may have a high impact to the business, but if things maybe do not work particularly well in the first iteration of your process, there can be a significant impact to the business. So obviously, let's try and show the business that there is value, but let's not impact the uptime of the business and have anything that is hugely revenue generating. Let's work with an application that is maybe managed by a central team that can be well connected to the entire ecosystem. Let's choose to move an application set that has less data. We don't want to choose our first application with petabytes of data to move. And we don't want too much complexity there in terms of the dependencies between that application and other dependent services. We also don't want to choose anything that's got a particularly complex third-party licensing arrangement. While we can provide some advice on moving that proprietary app to open source, it doesn't really make sense to choose a very proprietary application in itself to move and auto-containerize in the first instance. There are things that are probably going to lend themselves better to containerization in the first instance. And we'll talk about some of those as we go through. So once we've done that, choosing a series of applications to move into a wave approach can be quite valuable. So choosing those that might have a high business value but low effort to go and migrate and leverage the automated tools is a very good way to start and may show initial business value very soon. I often see these very large transformational projects that go over multiple years, and it takes, in some cases, years to show business value back. But if we can choose some quick wins and those that have a low level of effort to move, then typically we can get further investment and support from the executive team to continue with the program. Now, I'd say that in the tail end of this migration approach, it's going to be those applications that have a high level of complexity, large volumes of data, high levels of manual effort to go and implement, and those that maybe have low business value. So definitely there are some things we can do around legacy languages and converting older code like COBOL or RPG or assembler to more modern languages like Java, and we can do that automatically. But I would say that there are some easier ones to start with in the wave one. Now, if you think about Linux workloads, those that we can and maybe should containerize, start with your web servers. Maybe some application servers, multi-tier stacks like LAMP stacks and WordPress. Maybe Java workloads that do not have a specific licensing or proprietary lock-in to a particular platform. Maybe those that have some form of business logic in there. Some commercial off-the-shelf applications, as long as they're supported in a containerized and Kubernetes-based architecture. Any application that maybe has a bursty type of workload may need to scale out to the cloud very quickly. Any application that might have a sprawl of virtual machines attached to it, and we might want to manage that well and orchestrate some of that sprawl. And operating systems that we may choose might be Red Hat, Enterprise Linux, CentOS, SUSE, Ubuntu, Debian, as some sweet spot areas by which we're running our application on these OSs, and they're primary candidates for us to modernize as is. Now, you may choose to use a hybrid or a mixed deployment if there are specific kernel modules or maybe database VMs that don't migrate well to a cloud-based database or an open source-based database, or those that have specific hardware-based licensing constraints. You may choose to do more of an OpenShift for that. Now, in terms of Windows workloads, we could choose to automatically modernize with migrate for Anthos compatible workloads that might be running IIS or ASP.NET. Typically web tiers, once again, anything running Windows Server 2008 R2 or higher. Those that we typically may choose not to auto-containerize might be those that have hardware accelerated dependencies like GPUs. Maybe those that have complex low-level networking requirements or desktop apps, or those that have specific licensing constraints once again. So If we now move to this phased approach, and I've got a phased approach with an example app on the next slide that talks about 3-tier app, database, application, web tier. We'll go through the approach of how we can maybe extract and strangle that monolith and move to something a little bit more distributed, microservices oriented, and we don't quite get to the containerization piece within that view, but we can talk about how we then take the application itself and containerize certain components as we need to. So the first start of this monolithic transformation is really looking at the application itself and making sure that the application vendor has the tools to make any changes as required as you move it to a different platform. Now, you may choose an application that is running WebSphere or some other workload that has historically been deployed on-prem, but has support for your new modern platform. So we've got some examples there, but we'll focus on this architecture that we see, where I guess we've got our 2 web servers behind a load balancer, calling out to our application tier with our application servers. You got your content, your SKU price for your e-commerce application, your inventory, session cart orders, checkout. You've got your search server and your index, and that's talking to your backend primary database and your secondary there. So this is relatively common, right? I mean, a lot of organizations run this type of stack in a monolithic way. And all of this typically is running on premises in a data center. It could be running on a cloud, could be running in a partner-managed colo. But this is the starting point for quite a few organizations. Now, if you think about goals, often organizational goals are, well, let's try and move to cloud. It doesn't always need to be moved to the public cloud. It could be moved to a more modernized architecture on-prem. But we want to move to cloud because we want improved availability. We want high availability, we want resilience, we want scale. We want multi-region capabilities. We want to access new markets. Maybe we'd like to reduce cloud. Maybe our hardware is going end of maintenance and we'd like something that gives us more elasticity. Maybe we'd like to offload some of the administrative effort to the cloud provider. And I guess from Google's perspective, we often act as a customer's SRE, site reliability engineer, for a lot of the platform that we host with a Kubernetes engine service and with Anthos, which means that organizations can spend more of the time on the configuration they need rather than the underpinning fabric that will support their workload. And then re-architecting to custom microservices. Typically, organizations are doing this because they want that rapid time to market for new feature development. I want to release things much more quicker than my competitor, and I feel like microservices empowers me to go and deliver a greater agility, working in small batches, releasing things quicker to my consumer. Maybe they want to leverage innovation and break free from vendor lock-in. Maybe they want to be empowered by an open source platform, and maybe they'd like to take advantage of some of the more advanced security features or configuration and compliance management-based features. And in a lot of cases, I see extensions to machine learning and an evolution to MLOps for developers, stitching their application together with a machine learning platform. And often organizations maybe don't have a huge amount of skill set on machine learning per se, so they'd like to leverage a managed platform to go and extend their microservices-based application to machine learning. Now, if we think about the next level approach and having a look at those apps, there's a process called domain-driven design. And if we have a look at what the top level domains are for an example, discovered structure of how we might break out an application, we might break them out in different categories like demand management or candidate for compliance and reporting or recruiting or maybe applications or assessing or screening or interviewing or hiring. There are lots of different things that we could do for this recruitment-based use case, but really breaking out each of the domains into a domain-driven design helps us to identify some of the easier assets to move. And there's a whole workshop that we can run around this, where we might paste in some of those domains and aggregate them into groups to understand which ones should move together. Now, the first stage, I guess, or the first phase of having a quick win and decomposing that monolith is to take static assets and move them away from their current architecture. So this might be moving any static content like images or fonts or CSS. And essentially what we're going to do with this is reducing cost and leveraging a cloud CDN to reduce the response time to deliver that image to the consumer. Now, technical benefit is, well, there's limited management of having to maintain those static assets. Now, using cloud native storage, we can automatically replicate that content. We can leverage a cloud CDN to accelerate the servicing. We can build experience and confidence in running that production service on a cloud and maybe extracting it from that monolith as a starting point. Now, it looks a little bit like this from our original architecture, where we might take our cloud CDN, our cloud storage, combined with our cloud load balancing, whereas the web search database application is still running on-prem, connected via our perimeter firewall to our customers. Now, the next phase, phase 3, is focusing on APIs and building the foundation. So having an API management and services layer can really help insert that layer between the monolith and the consumers and connect the consumers eventually to your hybrid infrastructure. It's a good connectivity point, building that developer-centric portal, intrinsic security, analytics on the APIs themselves. And many consumers would likely leverage APIs to connect to the application through a web browser presentation layer, through mobile apps, or even through in-store systems. We typically see benefits with organizations in hiding that monolithic complexity. We can start to enable more omni-channel exposure to consumers. Bless me. And essentially leverage this functionality via a single and controlled and secure API mechanism. So what does that look like? Essentially, if we think about this phase in a visual approach, we've got our on-prem monolithic structure, but it is now connected via our API gateway. And our API gateway is serving out API definitions and contracts for content and SKU and inventory, session carts and orders and checkouts, still via the cloud load balancing through the gateway to those core e-commerce services, with the CDN still connecting customer requests above through to that perimeter firewall. So phase 4. If we think about this stage, it's probably midway through the decomposition of the monolith, where we're taking that presentation layer, which is the layer that most consumers' browsers are going to consume, and it provides the responses back to the browsers. So it maybe has this thin presentation layer on top of the API layer. It'll give you that responsive single-page application, or SPA. You might have your content management system for the front-end components and deploy that to a scalable cloud. Now, typically, this layer is something that I see running in containers too. Connecting that containerized architecture of your SPA and CMS via your API gateway to your consumers is a very easy, quick win for modernization. Now, I say to the business, they're going to see benefits in more regular releases. They're going to release much more regularly for feature updates to consumers than in the prior monolithic stack. So speed to market will increase revenue for businesses. The end consumer experience will be better because the SPA will be compared with pure HTML. It's going to be a more seamless user experience for them. And the business is no longer constrained by things that may be delivered to the consumer to the rules of the monolith, which is still on the back end with the database and certain other components. But essentially, it looks a little bit like this, where you've still got your CDN and your API gateway, but now we've got our presentation layer with our SPA and CMS, load balanced, and then connecting via our gateway through to our web servers, search, database, and application stacks. But essentially, we have elevated that presentation layer through a modern fabric now. And look, we say compute engine on this diagram, but I would say in many cases very easily containerized on Kubernetes engine. Doesn't necessarily need to be on Google Cloud Platform, but I would say that maybe Kubernetes should be underpinning where you run that. And consistency of that Kubernetes platform is key. I was reviewing a multi-cloud strategy for an organization recently in Australia. And one of the key premises for their multi-cloud strategy was having a consistent platform. And that consistent platform across multi-cloud and hybrid cloud was Kubernetes because they had consistency of performance and security and configuration and all of those things that meant that they didn't need to rework the application or refactor it to go and run in multiple different clouds. So luckily, GKE runs atop Google Cloud Platform, but also AWS, and soon to be Azure as well, in addition to on-prem with vSphere and bare metal. So let's think about the next phase, phase 5, which is focused on browse and search. So search will help to build that PLP, the product lister page. This is often JSON or XML, and often the browser interfaces with this to return a query from the consumer. Now, browse within an app or a page is often delivered through the PDP or the product detail page, and it's probably got a mixture of both static and dynamic requests. So this is also potentially a good candidate for containerization too, depending upon how it's being done. But we can definitely help evaluate the containerization fit propensity for that function. Now, I would say that PLP in terms of customization for business benefit is going to result in better search accuracy, maybe higher conversion rates for the application or cart function, and it's going to give much more of a customizable experience for the end consumer. Now, I see a mixture of customers maybe going to serverless platforms for some of these. Maybe they might choose to run containerized, maybe they might choose to run in a containerized serverless architecture like Cloud Run, or maybe they might choose to have their code just run in functions or even App Engine to maybe serve out some of these components depending upon what the application is written in and how it runs. But if we have a look at this example here, we have our CDN and our security with Cloud Armor and our Cloud DNS combined with our load balancing, a presentation layer for our content, our Cloud VPN, our dedicated interconnect, all on that cloud platform in, separate microservices that we could update independently, and then all connecting through to our on-premises data center colo location. So phase 6, and we're starting to evolve now into much more of a personalized experience for the consumer. This is essentially where consumers create that session when they go and browse that e-commerce site. So traditionally, a consumer session needs to be much more dynamic now than it was historically. So many kind of browse requests that we have are often in demand now to be recorded in a single session state, and having that session state be available as other sessions continue, maybe having that more personalized experience within the app. So by extracting this personalization or a session enabler, we're essentially lowering that performance impact on the monolith. So we're freeing up capacity on-prem. We're maybe scaling on a platform that is more dynamic with the cloud than the more monolithic architecture that sits on-prem or in the colo. And we have more of that one-to-one mapping of a session to the consumer with the app. And we could maybe call multiple channels and simplify that experience by having that session available as a separate microservice. So what does that look like in here? If we break it up one step further, we've got our SPA and our CMS now, and we've got our search service, session store, and our session services all running independently. I guess our search and our session stores stored on a cloud data store, whereas the search service and session service could be on serverless, it could be on a more traditional compute engine platform, or it could be running on a Kubernetes engine platform when we choose to containerize it. So we could do that initial move to the cloud, but then we could containerize thereafter, or we could move and improve, as I mentioned first, which is being able to containerize and move to the cloud at the same time, which is, I guess, where we see the interconnects between the prior slides and this one. So the seventh phase here is around decommissioning that monolith. So here we're optimizing the platform. We've completely strangled that monolith and migrated the services onto that new cloud platform. Ultimately, for the business, we have reduced their constraint on development. They have services that are easier to update without impacting the overall platform. There's a much lower TCO. They're paying for what they use and what they need. And the operational overhead is minimized, given the cloud provider is essentially running a lot of those services that might be typically more manually maintained by the on-prem or colo-based team. So this is ultimately what it looks like, where we add in that cache layer with the cloud memory store. We've still got our API gateway and our presentation layer, our services layer, and our storage layer there. So just a summary on some of these things. I can show you some additional views on how we automate some of these tasks. Essentially, the main principles that we followed is that every service should have its own database schema. Services should be communicating through APIs. Services are responsible for backwards compatibility for their clients, and there's a lot more kind of context to these that we can go through. But just to keep it simple, those are the first three, and the next two to comprise the top five are around having that standard way to run services in a development state, on-prem, in the cloud, regardless of where you run it, being able to develop on a form factor that's going to give you a similar experience. And investing in consistent monitoring, logging, trace, the full observability stack, making sure that if you are going to develop and decompose that monolithic architecture to microservices, that you have consistency of monitoring on the cloud platform where your microservices sit, but as you choose to scale or grow or move, maybe you have consistency of monitoring, logging, and trace on other cloud platforms. Or if you chose to leave some of those services, but maybe extract them from the monolith and run them on more of a distributed or shared platform on-prem, then being able to have consistency of monitoring and observability there too. So just in terms of automation, thinking about some of those earlier parts to the phased approach, where can we leverage some of this automation? So essentially moving those applications that have low resource utilization, maybe those that might have a lot of rewrite effort from development teams, those that are maybe front end or middleware based applications with supported licenses. We're essentially taking those applications out of the operating system, running them in a containerized architecture on top of Kubernetes, or moving them to a distributed cloud service that lends itself well to running that particular service. So as a serverless platform in an example. So in terms of the migration approach, generating those artifacts is going to be key. Having that testing, doing a bit of a data sync, and then deploying and integrating with CI/CD is the way that we would follow migration from generating the plan through to delivery and deployment. In terms of evaluation, being able to move workloads consistently and in an automated way from different endpoints is going to be key. So making sure that if you're running some of those applications monolithically on top of VMware virtual machines, or on top of AWS EC2 virtual machines, or Azure virtual machines, or even Google Compute Engine virtual machines, we have the ability to automate and containerize and modernize and optimize all with the same tool set. Now, in terms of that initial evaluation, we do have a demo that we can go through that shows how to go and migrate automatically to containers. And I'll go through that recorded demo after the last of these slides here. But essentially, making it simple to go through a wizard-driven approach, do it at scale, and essentially create some of these CI/CD artifacts automatically is what we see. And also evolving into having that automated discovery and containerization fit assessment available to evaluate the workload before we do the migration. So just to review all of the things in the ecosystem before we get to the demo, the things that typically comprise a modern platform, facilitated with that API gateway that we mentioned, providing analytics and API security, developer portal, that declarative config management for day 2 operations, and managed service mesh for security and observability across the microservices, centralized logging, monitoring, trace, and consistent management of clusters across all clouds, comes from a combination of Anthos and Apigee. Whether you choose to run the workload on Google Cloud or Amazon or Azure, vSphere or bare metal, or whether you choose to manage an EKS cluster from Amazon, or maybe AKS from Azure, or even managing OpenShift on-prem, having that consistency of the ecosystem to manage the workload is going to save effort. So with that in mind, there are some next steps, but I will skip past this one very soon to show you a video demo of how you might choose to automate that migration. Before we get there, the first 3 things that you might want to consider is enablement and empowerment of the team. Review many of the cultural guides. Let us help evaluate the culture with Dora for you and your team, in addition to the workloads in that application assessment. Build that business case to get buy-in from your executive team so that they can support you on your journey of modernization, and leverage the tools where possible to go and identify what's going to be a good candidate workload. And here's an example of the pre-work that you might want to do before you get to that migration, where you could use a free discovery tool to go and isolate the gaps that you may have, that you might need to manually update or change before you go and leverage that automated containerization. And then similarly, if you've got legacy code, what that may look like if you have legacy COBOL or assembler or RPG or something, and you want to move that to a more modern language like Java so you can run it in a container on Kubernetes. This is a tool set called G4 that will do that analysis and conversion for you. So with that in mind, let me escape from here, jump to here for you, and we can show you the automated containerization approach. So if we see here, we've got our Google Cloud Platform view and a number of migrations that we've run before, where we've got our source and the status of the migration, and I guess whether we're migrating just the image or the image and the data, and the cluster that we're moving it to, the location, etc. If we move forward, we can have a look at the options for the migration. So moving forward to migrate to containers on the left-hand side gives us the option to start a new migration at the top there, which you can see. So if we click on Start Migration, essentially the options we have are to give our migration a name, go and select the source of that application, what is that source virtual machine, what is the ID of the migrated virtual machine, and the intent. Is it going to be data as part of it, or image and data together? So once we do that, we go and click on Create Migration down the bottom. Now once we've clicked migration, we can track the migration progress. So we can see that we've created some snapshots, created the disk copies, created some persistent volume claims, and we're generating those artifacts. Now we can go in and edit that migration plan. So we can go and have a look at the YAML that we have generated, and maybe go and edit certain things. We can see the intent there is image. We can see that the kind of YAML is generated artifact flow. And we've got some files and directories that we choose to exclude from the migration. So we've chosen to exclude those. If we move through and save and generate those artifacts, we can see that we're generating artifacts there. And then next stage is to create our image. You can also download the artifact links and YAML, in addition to reviewing the artifacts like we did before. We can see now that the image has been uploaded. We've got access to all of those artifacts in here, to which we can now deploy our container image on top of Kubernetes with our YAML there. So ultimately, fast tracking one of the stages, which would be extracting that application out of its operating system and moving it onto a more modern fabric, to which it could be more portable across any of the multi-cloud architectures you've got. And also, I guess, extending the time of teams to go and spend efforts on decomposing other parts of the monolith. So with that in mind, I think that comes to the end of my time. Just wanted to say thank you to everyone. Do reach out, I guess, if you'd like any additional help or support. You'd like to do a discovery, you'd like to do a bit more of a deep dive on how it all works. You'd like to do a domain-driven design workshop or a DORA assessment. Happy to help with any of those things. And yeah, look, I think that's it. Are there any questions?
All right. So right now there are no questions that's coming in via YouTube or Facebook.
Sure.
So in the meantime, while waiting, if there are any, maybe I mean there are some questions that I went through my mind as I was watching your stream, your webinar. So maybe you can go from that first.
Sure.
So you mentioned that as part of the first phase, which is like part of discovery, is one is to map dependencies, right? Map dependencies between applications, like to understand like how data is flowing, etc. So as we all know, companies, they will continue to operate even while this whole migration process takes place. So during the whole map dependencies process, I would imagine that there are teams out there in the company will continue to develop more applications and add more complexity to to the whole software dependency, the whole software dependency of the company. So how do you deal with that? Like, do you like tell everyone to like, hey, slow down your application, slow down your application development, or like,
Everyone stop deploying applications. No.
yeah,
No.
like I mean, applications do they'll eventually add more complexity, add dependencies
Sure.
all over the place. So like, how do you deal with it? Do you have like
It's a
some
repeatable
automation?
process. Yeah, I think you can't just go and discover applications, workloads, utilization, and dependency once. It's got to be something that continues. And maybe as you prioritize the applications, you choose the ones that have the lower complexity first. And before you go and migrate some of the more complex wave 2, wave 3, wave 4 applications, you need to go and recheck your dependencies and recheck, I guess, the size, the utilization, anything that may prevent you from moving that application without with impact. So I would say that the other aspect is beyond just doing that discovery for dependencies, running that workload fit assessment tool that I showed right at the end. At the point in time that we choose to start modernizing is a good way to identify any hardware mapped or anything that might be hard-coded into the application that may prevent us from modernizing and moving that application as well. So a couple of different factors in play, but repeatable assessment, I think, makes sense as you're doing repeatable migration waves.
Okay, that kind of makes sense. I mean, we kind of had to do it if we are doing that approach. This whole migration thing, like, can't expect business to completely shut down.
Yeah, absolutely. You can't
development.
just assess once and then have a 3-year modernization or migration project and expect the state to remain the same. I think it's got to be a very dynamic discovery process.
Okay. Then another question that kind of came across my mind. I guess one thing, this thing will be of particular concern to many application developers would be during the whole migration process. Some legacy applications will be in virtual machines, and they know the performance of how the application will work on the virtual machine. But then during the whole modernization, I mean, you did mention that there are times where applications might be a better fit in container, but then some application developers don't buy that reasoning. Like, they will say that, oh, okay, when you move over to a container stack, that will mean that there's now an additional layer that will like prevent the application from talking directly to kernel to to do all your application calls. So like, how does one reason about with that? Like, do you have to do like some sort of performance test? Do you do like some kind of like,
yeah, so look, I would say performance benchmarking has got to be part of that initial discovery too. Let's evaluate what the performance looks like in the current state. With regards to containerization though, I would say that if you're running an application on a Windows or a Linux operating system, there is a lot of resource being consumed by that operating system. There's patch management, there are things that consume resources and essentially slow applications down. By having a much thinner, smaller runtime, we're essentially reducing that overhead for where the application runs and offering greater efficiencies to do things that we may traditionally do in an operating system to lock it down from security or compliance or configuration perspective. Maybe we don't need to do that in the same way if it's running in a containerized stack. So there's far less impact on where the application runs in a containerized view compared to running all of the agents and having to configure and lock down certain things in the same way that you would for Windows compared to a containerized workload or even a Red Hat Enterprise Linux virtual machine. I guess what I see and have seen historically is there are a lot of virtual machines out there. And typically they're not well optimized for the platform they run on. Having done a lot of virtualization in the past, organizations would pick up applications running on bare metal servers, physical servers with an operating system, and they do a P2V, and they wouldn't change anything to do with the application. But the application's running on a hypervisor now, and it's not being optimized. Like Java was a workload that was always a case that you'd move Java to a virtualized architecture, and it would perform incredibly badly because no one ever changed the Java heap size and many other things that you maybe need to look at in virtualizing. So I would say that first step should be that re-platform, move it to something else. Second stage should be to evaluate what that application needs on the chosen runtime, and then optimize according to the best practices that we have. Now, I guess the evolution of automated tools like Migrate for Anthos means that you can come in and run on an application container rather than a more generic runtime container. You may be able to run on a vendor-supported container image, like a WebSphere-based container from IBM. And I think that often helps because you're reducing that surface area of things that you need to configure, and it's now running in an artifact that is fully supported by the application vendor on top of a platform that minimizes the overhead. So I would say that there are many different angles to it, but hopefully that answers some of the question.
Okay. I mean, it does answer what I had in mind. Okay, so we finally have one question from the audience. So hold on, let me click on it. Okay, so the question is, do you think reading books is mandatory for coming up with good or best Microsoft, I assume, Microsoft migration strategies? Does real world experience be enough, and how do you build up this knowledge?
Yeah, look, I think that theory and books are great for culture evaluation. They're great for understanding the premise of what we're trying to solve for. I would say that real world experience and doing migrations is very valuable in being able to understand what works and what doesn't work. I would say that building knowledge has to be a combination of these. I spent many weeks sleeping on data center floors doing migrations early on in my career as you're waiting for things more traditionally to migrate. In the modern sense these days, we don't need to do that level of physical interaction with where we run our workloads now. But I do think that having an ability to pilot and try out the process first and getting the real world experience on how it works within specific customer environments is key. And trying to work in and across as many environments as possible. Not every customer that I've worked for has been the same. And I think being able to understand the constraints of certain organizations will change your process. And I'm doing a couple of cultural evaluations for organizations this week, 3 or 4 different organizations, and the approach for each of them is different because their organization structure is different. Some have DevOps, some don't. Some have containers, some have more traditional virtual machines and are looking to evolve. So I think being able to go in and adapt and evaluate based on the requirement and circumstance, I think is incredibly valuable. I think migration strategies are not static as well. We're continuously evolving in the way that we migrate and transform. And essentially learning new things as they come out is going to be key. I would say that many people may not believe in automated migration strategies because they haven't seen it work in their particular environment before. But I wouldn't close the door on some of these strategies before you've actually evaluated them for workloads and have used them as part of the tool set rather than the only solution that you take. Hopefully we've given a couple of different views on domain-driven design and SRE and extracting or decomposing or strangling that monolith, leveraging automation tools for migration, but also for discovery, that it hopefully demonstrates that it's a multifaceted approach. You've got to try a lot of different things, I think.
Okay, hopefully that answers our audience's question. Meanwhile, I'll ask like one or two more while waiting for more questions if they come in, and then after that we'll end it off here. The webinar has been going on quite a while. All right, so I have one question in mind that I think like it comes about quite often when it comes to monolith to microservices kind of migration move. So in the monolith, right? So you have all those like little like services of sorts that can all contact that one database, and all that data is all there. So it's like if you have like service A needing some data from service B, you can just like just pull it out of the database. So you have like some big ball of mud there. And let's say during the whole process of like moving, you manage to strangle out like service A out of that monolith. So now, and then as you said just now during the presentation, like it's best for like if you have your own service, right? You have your own like database that handles its own data so that you don't mess up everything. So how do you handle with that kind of situation? Like now you have service A that have managed to be extracted out from the monolith with its own database. So, and then you have service B that relies on service A's data, which used to be in the database of the monolith, but now it's somewhere else. Like now, like how do you do with that? Deal with that?
Yeah, well, look, I would say that you can probably choose to move dependent applications together. I would say you're probably not just going to move your application A and its dependent database once and then wait 3 months and migrate application B. Hopefully as part of your discovery and your migration plan, you understand that we've got application A, B, C, and D that are all relatively dependent upon each other. And in a lot of cases, these modernization activities are not completely online. Like you do need to take some form of outage to switch from one platform to another. I guess you can minimize that approach through making the refactoring faster with those automated tools and reducing the amount of downtime that you have. But I would say that you probably need to move application A, B, and C all at the same time and make sure that you are driving them towards a cloud platform that can serve all of their needs. I had a conversation recently with a customer that suggested that they want to move maybe application A to the cloud, but maybe application B could only run on-prem. Now, that's really going to determine where you choose to run both of those workloads, given you might have a constraint for one application that is heavily dependent on another. Maybe both need to stay back on-prem. But it doesn't say that you can't modernize both. You can surely containerize both in place on-prem where they sit and gain some advantages to optimizing the platform they run on and building in that intrinsic security, maybe having your managed service mesh across the stack and declarative config and building in CI/CD to help lifecycle and provide updates to the app. But I would say just the choice of where you run it maybe changes when you've got some of those constraints.
Okay, that's a good point. Okay, I guess we'll go with this as the last question. So our same audience member raised another question. So his question is, at what point do we say like, no, we don't need any more containerization for this, and it will be overkill? Like, what are the key aspects where to arrive at this decision?
I like Dan. Dan, you've got some funny questions. So look, I would say, at what point do we say, no, we don't need any more Windows and Linux operating systems? I would say it's heavily dependent on the application and whether the ISV or the application vendor can support containerization. I'd say that In a lot of cases, there is limited benefit in running a heavy operating system these days, unless your application requires it. I would say that the benefits of containerization extend beyond Kubernetes. The evolution from bare metal and physical servers to virtualization to containerization to orchestration with Kubernetes to serverless to whatever else is next to functions, I guess, really lend themselves to how do we minimize the underpinning platform that serves our applications to our consumers. And there are so many benefits to extracting this application out of a very proprietary operating system stack that I would say the point would be when the applications cannot run on top of that stack. I would say that key aspects to make a good design decision would be oriented towards performance, would be oriented towards security and manageability and availability and recoverability and cost. And if you can weigh up those 6 things and compare it to the current state of running in a virtual machine and say that it is not better in a containerized architecture, I would be very surprised. But really happy to go and evaluate those 6 things across many of the apps. And as long as the application can run on top of that stack, and I guess does not have the constraints around huge amounts of complexity or stateful data or things that maybe should be diverted outside of the container to distributed cloud services, I would say that that's probably a good starting point.
Okay. Hopefully that answers your question then. So Andrew, do you want to take one more question? I mean, one more question came up from the audience.
Why not?
All right.
Why not?
Okay. So a question from SM Tan, 2011. What are some of the biggest challenges you have faced to date?
Thanks for the question, SM Tan, 2011. I would say the biggest challenges around this journey of monoliths to microservices is just not having enough information. I would often start a discovery with a customer or with a partner, and if you don't know anything about what you're trying to migrate, it's very difficult to build an approach around it. I would say that maybe some organizations are a little bit averse to doing an automated discovery that leverages a service account to collect data and map out dependencies. And I would say that without the level of information, it's really difficult to choose your modernization approach and invoke any type of change. But I think the only constant that we have is change. People aren't running the same architectures that they're running 20 years ago, and they won't be in the next 10 to 20 years. And the only thing that we can continue to do is continue to evolve, which is also a big challenge, right? To continually evolve in this industry is incredibly hard. There is so much that is constantly new in our space that we need to relearn and try and be experts in. And I would say that evolving practices to accommodate those new things and coaching others to onboard with those new things is a big challenge. And not having enough information to empower them to adopt those changes is the biggest gap.
All right. So hopefully that answers your the question raised by SM Tan 2011. So, okay, with that, I think we can kind of like stop the webinar here. It's been running for quite a while already. So, all right. Thanks, Andrew. Thanks for your sharing on this whole application modernization. I mean, it is kind of a treat to kind of get like speakers to talk about this whole process, because like, not many people actually work with this whole like this whole domain, because like essentially usually you will need to work with those big companies. I mean, smaller companies, they will have already been might have already been started using the more modern technologies, but bigger guys, they tend to be on the slower side. So yeah, it's kind of rare to find get some understandings regarding this. So all right, thanks, Andrew.
Thank you so much. It
Hopefully,
was great. I look forward to the next one. Keen to see what the session's about.
all right.
Thanks so much.
I'll put you on backstage for now. Okay. So just a few quick announcements before we end this webinar. So um, one is we have a La Copy session by the Google developer space that's coming soon on machine learning, and that's on June 10, 7:30 to 8:15. And then, so for those who are interested, you can just join that session. And then we have another session by Google GDG Singapore. They'll be covering on the topic development, this big O N development, engineering productivity metrics and morale. I guess a bit covering on, like, how to deal with good mental state during this whole situation. So those are the two major talks that is happening like sometime this month. So if you're interested, do catch them. And with that, as usual, GDG Cloud Singapore is always constantly looking out for speakers. It has been a dry couple of months because I mean, like, it's kind of hard to get speakers. That's one, and secondly, uh, it's all webinar based, so it's kind of less interesting, less exciting, I guess. So I mean, if you are in, if you happen to come across a topic that you wish to talk about, yeah, do reach out to this URL and sign up and like pass your topics over, and then we'll try to arrange a session. You can talk about any of the topics, like you can if you have like a Kotlin based kind of topic, or maybe a TensorFlow based kind of topic. You might not be talking at a Google Cloud webinar event, but maybe a GDG Singapore event. So just reach out via that URL. And as usual, do follow us on any of these social media. If you like the content for the webinars and everything that's being hosted. So we have Facebook, the Facebook links there. Slack, if you want to kind of reach out to other people and discuss about Google Cloud related stuff. That's all there. And then if you want to keep a lookout for what events that might happen in the future, there's Meetup and as well as these GDG sites. So GDG Cloud has moved to GDG site. So in terms of the latest updates on what events will happen, we'll be updating on GDG site first before it lands on Meetup. So if you want to be updated on what's happening with the GDG Cloud Singapore Meetup group, do sign up and follow along on the GDG sites. So with that, that's the end of this webinar. So hope to see you guys in the future. Bye bye.